Savina Singh, the Director of Intellectual Property and Commercialization at UKZN InQubate, which is the innovation office at the University of KwaZulu-Natal. We have a focus on technology transfer, consultancy, as well as student entrepreneurship. The hosting of the World Science Forum in South Africa this year is a wonderful opportunity to bring the spotlight on the excellent research being undertaken by South African scientists. At InQubate, we try to ensure that our efforts are directed towards addressing significant challenges, which invariably has relevance locally as well as internationally. We work hand in hand with our researchers, industry partners, as well as our funders to translate this research into solutions which can benefit society, the economy, as well as the environment.
Our team at the Catalysis and Peptide Research Unit has developed a series of novel metallo-beta-lactamase inhibitors using synthetic organic chemistry. Existing antibiotics have lost their potency due to infections caused by resistant bacteria. So antibiotic resistance globally now is referred to as the silent pandemic because it claims the lives of more than 700,000 people annually. So our lab has developed novel metallo-beta-lactamase inhibitors that's able to restore the activity of existing antibiotics in the presence of this resistant bacteria. And this is important because currently there is no clinically available metallo-beta-lactamase inhibitor on the pharmaceutical market. Our hope is that we could partner with a pharmaceutical company and take these compounds to commercialization and hopefully reach a patient so that it can help save lives and essentially treat antibiotic resistance.
So the technology that I developed is for autopsies. We manually transcribe all the information from our autopsies into paper reports. These paper reports are then used for court purposes. But we extract information for things like resource purposes as well as for statistics. So originally it was my own personal research for a project because I just found when I was doing my master's, it was very hard to get information to do my research. So I had to go into like a big facility with lots of files and go through manually. So I thought maybe it'd be easier if we could create something that would store all this information. So the technology was created to improve our manual recording system because we now have the technology to have electronic record systems. The application is you enter it straight after your autopsy, you enter all the relevant information. It then instantly reports, gives you a report on the app, and from there you can instantly create statistics. So related to age, gender, race, as well as cause of death, and as well related to what happened, so the history. So the doctor, once they perform the autopsy, they immediately enter the information, and that information is automatically sent through to the cloud and sent through to create the statistics. So if somebody at the end of the week may even comes and asks, has been a large increase, have you noted a lot of people maybe dying from COVID, because that's also one of the things that we looked at. So if you're seeing a large increase, it can automatically be sort of flagged. So this can be like an early warning, and so that's how it will impact socially as well as the government. So I created this application. First, it started off as my pet project because I wanted to use it in my mortuary and for research purposes and my students. But ultimately, I saw like a bigger goal. I mean, it could be used in other mortuaries. We could have actually provincial statistics. We could also have national statistics.
A group of researchers at the University of KwaZulu-Natal have developed a thin film organic semiconducting material that has fascinating electronic properties. The material can change from an N-type carrier to a P-type carrier merely by changing the composition of the two components of the material. This induces remarkable electronic properties that make it useful as a saturable absorber in a medical laser, as a communication device, in cell phones, as a transistor, and also as a radio frequency transmitter.
The aim of this project is to actually replace the currently commonly used material, which we all know is silicon, which has got good efficiency. However, it has got its own challenges. It's got rigidity as an issue, it's not flexible, it's not biodegradable, and it's not cheap. So our project looks at an alternative, a more sustainable approach. And in this case, we're looking at this material that is flexible, it's biodegradable, it's easily available from the biomass that we have, which we are rich in. So far, we've been able to actually achieve good efficiency, and it shows quite promising in terms of solar panel properties. We should pay attention to this project because it's an exciting project. The material shows good flexibility, one. It shows good properties. It is flexible, renewable, it's cheap and sustainable relative to the common known silicon. Hence, it has got good feasibility.
Our contribution will be vital to South Africa since it will not only help in resolving energy issues, however, it will also open doors to create greener products. In addition, it will also assist in job creation and also increase the manufacturing capability of this country. This work addresses United Nations Sustainable Development Goal number 7, which advocates for clean, affordable, modern energy for all.
This technology being developed, it's a low-cost inverter. I'm using solar panels to generate electricity mainly for domestic use and for small restaurants and for small shopping centers. So we started by looking at documents from the Itekweni, where they published what they considered to be the electricity consumption of the average household in the Durban area. And then we factored a few other considerations in it, and we came up with the conclusion that an inverter the size of 10 kVA will provide a household enough electrical power. There are a few places in rural communities where the electricity supply is not available. So we were looking at how do we improve the possibility that, again, a rural secondary school will be able to have easy access to electricity to do their homework, okay? So this is what drove the design of this project. As for the importance and relevance, the issue of supporting a green society is definitely one. For people who are remote from the grid, the inverters are very helpful for them. And at the beginning when we started, there was a local company which was interested in adapting this technology to manufacture and market it in South Africa and export it across the border to countries where the electricity supply is not as good as it is in South Africa.
So if I take you back to my beginning when I started studying, it was not uncommon for us to be told we can't really do much to accelerate wound healing. But what has been interesting is that technology changes, medicine brings in more science, and certainly through a process of observation that doctors have in treating patients, what became very apparent to me that there are ways and means of improving wounds per se. So having observed how tissue expansion worked, really as part of my early portion of the training, and when I became a consultant, it gave me an idea to see how is it that we can still expand tissue, expand skin, but use something without operating, use it on the external surface. And that's where the idea of use of tape, which is simply a simple tape used for wound dressings, holding dressings onto skin. We use that to apply a mechanical force to stretch skin. What has been happening in terms of wound healing, other than the chemical side, other than the hormonal side, but the thinking that using a mechanical force can change the way wounds heal. And one of the first kind of mechanically orientated devices that came out, we referred to as vacuum assisted closure. Now, just to give an idea what that really is. So a wound is dressed, a vacuum or negative pressure is subjected to it in an occlusive environment. But by putting the negative pressure onto the wound, a lot of different things were happening, right? And through the mechanical force that was generated by the negative pressure, healing was improving, wounds were closing, and this was happening not only because we were able to increase the way the blood supply to the wound changes, but even cells behaved and tissue behaved differently. The technology that we came up with is we were just using a tape and we were strapping that across wounds, and we were using a very manual technique, use of hands, a paper tape, a scissors, and what have you. So it came a time where we needed to make the process less cumbersome. So a device was created over a period of about 4 to 5 years where we were able to deliver the tape, apply the tape, and use the tape to migrate tissue and apply that force so we accelerate and improve wound healing. The device that we've invented, essentially the name we've called it is tape assisted closure. Now what that tape assisted closure means to us is that we're using a tape to apply to a wound and skin around it, applying the mechanical force because we're migrating tissues under the tape, and that tape then holds the wound closed for us. And by holding it in that position, the tissues actually feel a traction force, they will feel some form of compression, and this is the mechanical force that then acts on the biology of the cells in the wound and the tissue around it. And as it activates the biology, we anticipate that it will help in assisting accelerating wound healing. And certainly for the problematic wounds where wounds are not healing the traditional classical way, we expect to have fairly good breakthrough in terms of dealing with those kind of patients who are sitting with difficult wounds, and we hope to make a change in their lives with the use of this device. I think from a cost point of view, I have no doubt in my mind that this is going to be cost effective and certainly effective in terms of its surgical goals that we've always, more often than not, reach with the use of the device.
So quantum communication is a vital application for the encryption of information, and you can think of it as being used by not just sectors where information needs to be protected, but for medical data, for the banking sector, for energy systems, for optical communication.
Anywhere where you need to secure information is where this type of technologies can be implemented and deployed. It is for that reason we develop quantum communication. Unlike classical encryption techniques, it's a physical process of ensuring the security of information. So the main objective of the technology is to develop a quantum network. So this would mean networking free space quantum communication with fiber-based quantum communication technology. Free space quantum communication would mean networking point-to-point as well as satellite technology into one network. Now, the technology that we developed is a prototype for single photons, which is required for quantum communication. It is a portable source that can be used in a free space link, which is probably a point-to-point between two positions where you have a transmitter and a receiver, or it can be a payload for a condensed satellite system where you're sending single photons from a satellite to a ground station or vice versa. So we are working on developing a ground station at UKZN, and the aim is then to couple to a quantum satellite that has been already launched. So by transmitting keys from the satellite to the ground station, we can generate a secure key that can be used for encryption. So since quantum communication relies on single photons, one method of generating these single photons is by attenuating a laser source. The other method is through the development of an entanglement source, which is what we developed, a prototype for a single photon source where the photons are entangled. So basically what we do is we take a laser beam and we pass it through a particular crystal that allows us to generate entangled photon pairs. This allows us to transmit one photon to the transmitter and the other to the receiver, which allows you to generate a key. Now, the advantage of these systems is that the generation of the single photons are autonomous to the crystal where it is produced.
This technology is a miniaturized weather monitoring system, and it also has attained very significant cost reduction over existing system. It provides wireless capability, and also it's expected that on the full completion it will have sufficient artificial intelligence techniques embedded to make it a smart weather monitoring system. We are currently having the rain monitor running, and you can see streaming data on the computer. Now, all the sensors, they transmit their data to a base unit, which is here. So then the base unit can transmit a kilometer away to this data collection center, and then the data collection center is receiving the transmissions here and then taking it through a communication channel into the computer, and a basic Visual Basic program was developed to help process this data and then display it on the screen. Okay, so on this particular one we have the rain sensor, which has some infrared assisted detection. Then there's light dependent resistors to measure the sunlight. So you can see we're actually streaming rainfall, which in the room there's no rainfall, so it's almost zero. And then there's a measurement of the light intensity. Okay, there is a unit here. This is a very, as I explained earlier, this is one of the new developments that we have in this project. This is a wind sensor. It has 16 sensors. We first built with 8, and then we escalated to 16, and we're comparing them at the moment. Okay, but it allows to measure wind speed and direction very, very well. And then finally is here the humidity and temperature sensor. Okay, this is the humidity sensor, and here is the temperature sensor. And if we activate them, the software might begin to transmit to the data collection point, which would then transmit to the base unit, communication unit. This technology is important because it's for the first time giving us cheap methods with which we can predict things like flooding. We can predict things like wildfires, which we know are becoming very rampant these days. And with the aid of artificial intelligence, we'll be able to look back at the typical weather conditions that precede drought. And with the detailed measurements that we're achieving with these devices, it's possible to be able to predict ahead once we've been able to study the past. And of course, there is the side, the economic side, that an integrated system like this produced in South Africa leads to new streams of manufacturing, leads to new employment. The unique thing about this technology is, first, it introduces two new sensors. One in wind measurement, and this exploits the biological systems like what crickets and cockroaches do when they evade prey. So we've been able to translate how they process the environmental signal based on how predators disturb the wind pattern around them. So we've tried to translate this into an electronic system that has an equivalent capability to detect very small changes in the wind profile. We've also taken a sensor which, for the sake of IP, I may not mention the name directly, but we've miniaturized the detection of rainfall.
We featured a few technologies in our portfolio which we've advanced significantly through research and development and which are ripe for commercialization. Our technologies are strongly aligned with the United Nations Sustainable Development Goals, and we're intentional about this because we try to make a contribution towards sustainable socio-economic developments. We're open for partnerships and collaborations, so please do contact us.